All right, now, they won't all come nice and spelled out for us. So let's tackle this one next. Evaluate the integral over d, where the double integral over d of 4xy minus y cubed dA, and d is going to equal, d is the region bounded by might want to draw the D out here, yes. Region D. All right, so y equals square root of x. Looks like that. And then y equals x cubed. Looks like that. So, this is the region we're talking about here. Yeah, so we'd need, basically need where this, we obviously know it's 0, 0 intersection. Then that intersection, yeah, is where x cubed equals the square root of x. So that'd be x to the 6 equals x, square both sides. So that's going to be 1. 0 and 1, right? Yeah. X to the 5th minus 1, the solution is x equals 1. So it's 1, and then this, of course, is 1. So it's 1, 1 to 0, 0. It's our intersection points. All right, so now, really could have an option here. Because I don't think it's really going to matter, is it? Because if we go this way first, that's going between functions of x all the way through. Or if we go this way, it would be okay as functions of y. X is functions of y. That'd be okay because it would still just be the same one all the way through. Okay, so I don't think it'll matter, but the way the region is written, the boundaries are written, it's y is function of x's, right? So it would probably be better, and we won't have to change anything, to go this way. So let's evaluate that. Let's do it with respect to x and then y, because of the way they're set up. These are functions of x. So, oh, sorry. We've got y as function of x, so let's do the derivative with respect to, integral with respect to y first, and then x. Yeah, because our y's are in terms of x, so we can go from the square root. Oh, which one's first? Which one's our lower one? That's the x cubed one, isn't it? So it would come first, so that x cubed. The upper one is the square root. And then our x, what about our x? 0 to 1? 0 to 1. Okay? I don't think it turns out too bad here, but yeah. Yeah, just getting it set up is sometimes the fun part. So we're going to respect to y, so yeah, it'd be, the x is constant here, so it'd be y squared over 2, so it'd be 2x y squared. 1/4 y to the 4th. And we're going to run that from x cubed to square root of x, and then we're going to do the integral with respect to x. All right. So it'd be 0 to 1. These are the y's, so it'd be 2x times the square root of x squared. Square root of x squared would just be x, wouldn't it? This will be 2x squared. Minus 1/4 the square root of x squared to the 4th. So it'd be 1/2 x squared, or 1/4 x squared. All right. Then we plug in the x cubed, so it'd be 2x times x cubed squared. So that's x to the 6th, so it'd be 2x to the 7th. And then 1/4 x cubed to the 4th. Be minus 1/4 x to the 12th, yes. Okay. These are at both x squared, so what does that give me? 7/4 x, okay. 7/4 x squared. And so we do the antiderivative, it'll be 7/4 times 1/3 x cubed, so it'll be 7/12 x cubed. And then we have minus, that would be 2/8, so it'd be minus 1/4 x to the 8th. And minus minus makes a plus, so it'd be 1/4, so it'd be 1, be x to the 13th, so I have 4 times 13, is that 52? Does that sound right? So 1 and 0, they were nice about that. That's just going to be 7/12 minus 1/4 minus 1/52. Basically what it turns out, right? If x is 1, we just get the fractions there. If x is 0, everything's 0. So it's just 7/12 minus 1/4 plus 1/52. Yes. 55 over 156. Yes, we are indebted to calculators there. Okay, all right. Now, here's the next one. Yes, sure. Would have been x squared, or y squared, and the cube root of y. Yeah. Okay. Here's our next one to consider. Double integral of 6x squared minus 40y. And D is the triangle with vertices 0, 3, 1, 1, and 5, 3. So yeah, it does need to start off here with our region D. So we got 0, 3, 1, 1, and 5, 3. Scalene. You got a scalene triangle. Yes. All right. Well, one difference here that we have is, first of all, we don't have anything as far as functions. I mean, well, this boundary, as far as the function would be easy, that would just be the horizontal line, y equals 3. All right, but what about this one and this one? Well, they're lines, and so, yeah, we're just going to come up with y equals mx plus b for each of those lines. Now, this one I think is the hardest one. You got, 5, 3, and 1, 1. So the m would be difference of the y's, 4 over, difference of the y's, so 3 minus 1 would be 2 over 4. So it'll be a half. And doesn't quite give us the b either, and so however you want to, but if x is 1, y is 1, we have y equals, 1 equals 1/2 plus b, and so that makes b a half also, okay? So that one's, that one there is 1/2 minus or plus a half. Wait, let's see. 3 minus 1 over 5 minus, yeah. We're good? Now this one's a little easier because we got the b is 3. The slope, yeah, so down 2 over 1, so it'll be minus 2, yeah. So sometimes you have to come up with your own functions there. Now, the next thing is to figure out, do I want to do the double integral, do I want to do the x's first or the y's? And note here, if we do the x's first, that's going to be more difficult. Here's why. Because if I do the x's first, remember I'd have to go from here to here, and it changes. So over here, so basically I would have two, here's what I would have if I did the x's first. I would have to divide this up into two d's, d1 and d2. Now what that means is I would have to do two double integrals. Okay, because there I would do that one because it would go from this one up to that one as far as the x's go, and then whatever the y's are. But then I would have, a second one, which you can do, and it's fine. And if you do it that way, it would work out. But you are doing two double integrals, and one double integral is plenty usually of work. And so it might not be the best here to do it that way. What if I changed it around and did the integral with respect to y first? Well, then it's not as much of a problem because now I'm just going from this line to this line. And that's the whole way through because this one just turns out to be straight across there. So I don't have to do two double integrals there. So I'm going to integrate with respect to y first. So and then integrate with respect to x. Now, 6x squared minus 40y. And I can do that with respect to y or x first. Neither one's going to be that much of a problem. So that's what I'm going to do. Now the thing is, if I integrate with respect to y first, I need nope, sorry. Start over here. Integrating this way is I'm going between my y values are actually from 1 to 3 here. So actually I need the x's to go from this to this, right? That's really what I'm doing. It's a little different. Yeah, I have to think in a little different way maybe than I have previously. And that could throw you off. It's throwing me off a little bit. So yeah, I'm going from 1 to 3, but for the x's, I'm going between these lines. And so that is integrating with respect to x from here to here. This would have been the y's. Okay, so hopefully I don't have you totally confused there. So yeah, I'm going, for the x's here, that's what I'm, this to this. Yeah. So I need what x equals here and what x equals here. And so that, what I have to do is change these over from y equals to x equals. That's basically what it boils down to here. Okay, so if we have the lower one is y equals negative 2x plus 3, and so I need to change that into x equals instead. What would be minus 3? So I have y minus 3 divided by negative 2. So it would be minus 1/2 y plus 3/2. Would be that one. So that's my lower one. And then the upper one, we've got y equals 1/2 x plus 1/2. And so I want to change that to x equals, multiply by 2, so it'd be 2y equals x plus 1, so 2y minus 1. That'd be my upper. And so then I go y equals 1 to 3. Yeah, it is a little tricky. I mean, yeah. All right. So let's see if we can, because this one, yeah, it does turn out to be a little tricky on some of it. Not too bad. Okay, so that would be doing with respect to x here, so that would be x cubed, so it would be 2x cubed minus 40xy. And we're evaluating that for x equals 2y minus 1, upper limit to negative 1/2 y plus 3/2. Oh, yes, that's what I was saying. So it'd be 2, that is x, so it'd be 2y minus 1 cubed. And then we have minus 40x, sorry, minus 40 times 2y minus 1 times y. If we plug in the 2y minus 1 for the x. Then we got to turn around, so it's not exactly easy, but all right, so now we plug in that for x, so it'd be 2 times negative 1/2 y plus 3/2 cubed minus 40 times negative 1/2 y plus 3/2 times y. Okay, now here's the good news. We could cube that out and all that, but it actually, when we go to integrating this with respect to y, sorry, so next step. Yeah, we can just use a u substitution. So let's just leave that, for now, let's just leave that. Yeah, we're going to do this integral with just u substitution. This one I'd probably go ahead and multiply out, so that's what? Minus 40y, so it'd be minus 80y squared. And minus 40y times 1 would be plus 40y, right? And then same thing here, I'm going to leave that, but over here, if I multiply that in, minus 40y times that would be minus 40 times minus half would be positive 20y squared. And then minus 40 times that would be minus 60y. For that, and that would be positive, sorry. Minus 40 times minus 1/2 would be positive 20y squared. So I have the y squared there. I mean, you can do more steps if you need there, but I think that's what I got. Now, those give me some like terms, but remember this is also minus, so that'd be minus 20y squared. So that's going to make it a minus 100y squared here. And this is 40y, but that minus makes that a positive, so that'd be positive 60, so that'd be 100y also. And then we're just going to leave this as minus 2 times negative a half y plus 3 halves cubed. We could FOIL that out, but I think we can handle it with the u substitution. Yeah, if we let u here be 2y minus 1, then du would be 2 dy. And so du over 2, we have a factor of a half, so that'll cancel that out. So it'll just be the integral of u cubed, right? So that'd just be 1/4 u to the 4th, so it's 1/4 2y minus 1 to the 4th, okay? Then this, of course, is power rule, so that'd be 100 over 3 y cubed, 50y squared. And then here, same drill, u equals, what? Which signs? Yeah, that one's got a cube, so I can't. All right, so it'd be u equals negative 1/2 y plus 3 halves. So du would be just negative 1/2 y, 1/2 dy. So it would have a negative 2 factor there, so that'd be a positive 4. Because I'd have that 2, minus 2, and that minus 2, so those would kind of multiply together. So plus 4 u cubed, so the antiderivative is 1/4 u to the 4th, and so that would be 1/4 1/2 y plus 3 halves to the 4th. And we're going to evaluate that from 1 to 3. Let me just give the answer and see if you get it. It's negative 935 over 3. Well, I worked it out ahead of time there. Should get negative 935 over 3.